let's say Selenium Maven dependency, and we're going to add a dependency from here. Selenium Java, the latest one, we can add it. That is from here. I can copy this and just a second. Give me a second. It's being a bit slow. So what I'll do, I'll add this dependency over here, and as soon as I add the dependency, it will actually gonna update the jar file in the Maven dependency. If the jar file is not present, it will actually gonna download it from the Maven repository, and then it will gonna add it over here. Right. Same way, I'll search for the testng dependency as well and add it over there. This is the testng dependency, and I can add the latest one. This one. I'll go back to my project and paste this as well over here. Right. So it will gonna take a couple of seconds, and it will add these two jar files over here, and then we are ready to code for our project. Right. We are ready to write the code for the project. So give it a moment till the time it downloads all the files, right? So what I'll do, I'll like pause the video from here, and then I'll continue as soon as the dependencies are being added, right? So I was missing this dependencies tag over here, right? We need to add these dependencies inside the dependencies tag. As soon as I have done this, it has actually started downloading these dependencies from the Maven repository. So as soon as the entire dependencies are being downloaded, it will be mapped inside this Maven dependencies. Right, it's almost done. So if you see over here, all the dependencies are being added, right? So next thing, I'm gonna create a new test, and let's say I give it a name as any name I can give to this project. Let's say login test, right? And in the login test, I'll create some methods. Let's say public void setup. This is a setup method which should be responsible for, let's say, I'll say public static web driver. Right, I'll call the web driver, and then I'll say driver equal to new Firefox driver. Right, I'll import these dependencies, and I'll import the Firefox driver as well. Then I'll create a test method that is public void login do login, right? And let's say I can visit to a website that is driver.get http gmail.com, right? And then I can say driver dot find element by dot xpath, or let's say by dot id, since I remember the ID of username and password, so I can say by dot id email dot send keys, and I can give some username that is trainer at way2automation.com. After this, I'll say driver dot find element by dot id. I'll give some password. This is the ID of the password element, and that dot send keys, and I'll give some password over here. Right. After this, this should be my test. So I'll add the rate test annotation over here, and I'll import it through test-ng, right? I'll import it through test-ng, and then I'll add the rate before suit over here, before suit or before test, whatever you want to do. And then I'll add a tear down method, and this will quit everything, so it should driver dot quit, right? And I'll say add the rate after suit, right? I'll save it. So let's run this and see if the test is working fine. Then only we're gonna check in to the remote repository, right? So right now this is not even a Git project. To make it a Git project, we first need to send it to the local repository, and then only we're gonna push it to the remote repository. So first we're gonna check whether this test is working fine or not, right? So it has actually opened up the browser, and it's going to Gmail. And enter username, password, and then quit, right? So the result says that the test is passed, right? Now let's go to the location where this project is maintained. It is inside C drive get maven. So I'll go inside this directory, right? The very first thing is to make this project compatible to Git, right? So that it can support the Git process. So in order to do that, now before doing that, I just forgot one step. Since we have actually created a Maven project, right? So I should test it with Maven itself, and I can see whether this thing is working fine with Maven or not. So since I have a Maven plugin installed over here, so I can right click on the form and I can run the Maven. I can run a phase called Maven test, and let's see a build is successful or not, right? So it will perform all these actions, and at the end it will execute a test. And because this is very important to see whether a build is successful using Maven or not, then only we're gonna deploy this build onto the remote repository, right? So over here we can see that one test run and the build is successful. So it means that whatever code that we have written, that code is running absolutely fine through Maven as well, right? And now it's time to push this code onto like the local repository first, and then we'll move on to the remote repository, right? That is on GitHub. Now we already have a remote repository created over here, right? That is WebDriver Maven, and I want to actually push my code onto this repository, right? In order to do this, first I actually need to make some connection in between my remote repository and my local repository. So in order to do that, we need to take a look at something that is called as a secure shell cryptography. I'll show you that. So far we have seen that these are various features, social and watch feature of GitHub that's been provided, which you can use. And then we have seen how to create an empty repository. We have followed all these steps, right? And now secure shell cryptography, right? The SSH key that we gonna use. So GitHub uses secure shell cryptography technique in order to securely connect to remote repository to Git repository, right? Otherwise everyone can start, if it is a public repository, then everyone can start adding their code onto your repository, right? So there has to be some secured connection that Git will gonna provide, so that only you should be able to do the pull and push request from the project that you are working on, right? So there is another technique that is known as RSA algorithm. You might have heard about RSA tokens, right? So RSAs are another keys that will be I mean, that is what Git is internally working on. The algorithm of RSA, right? So there will be two keys that will be generated. One is public and the other one is private. The public key resides on the centralized on the remote repository itself, whereas the private key is for your local machines, so that they can have, because private key will be private to you only, right? For the code that you have on your local machine that you need to push to the remote repository. So if the private key of local machine matches with the public key of the remote machine, then only the connection will be made, otherwise that connection will be refused, right? So this is one of the diagram that I've created, how these RSA keys are paired. Let's say this is one client, this is one client, and this is a server. This is a public key, and this is a local, a private key. If these two keys matches, then only the connection is performed, right? And then all the clients are able to sync with the server, the one server. When the keys, the public keys and the private key matches, right? So this is how we're gonna see how we can actually set up the entire process. So this is only a one-time effort, right? This key generation is only a one-time effort. If both of the keys are paired once, then next time whenever you are trying to push your code onto the remote repository, it will just gonna check whether the key matches or not. If the key matches, then it will actually gonna push your code onto the remote repository. So you need not to generate these keys again and again. This is only a one-time setup. There is actually another way of doing this as well. If you don't want to go through this process, then every time you check in your code, Git will actually gonna ask you for your user account details, your username and the password, right? So every time you're pushing a code, it will ask for a username and a password, then it will actually gonna push it to the most repository. But if you do this pairing, then it will not gonna ask you the username and password again and again, because this is just one-time setup. Now let's see how we can generate the SSH keys, right? So these are the following steps that I have mentioned how you can generate a key, right? You need to open up a git bash. So git bash, I'll go to git and open up the git bash first, right? This is my git bash, and I need to type this command, that is ssh key gen and hyphen t. T says T denotes what the type of key is. So key is basically RSA. So I'll press enter, and it will say generating public private key RSA key pair, enter file in which you want to save the key. If you press enter, so on my machine this is already exists. If you see, if you go to this location, C drive, users, Selenium, and if you see, there is a .ssh folder generated over here, right? And you're gonna find two keys over here. One is this one is public and this one is private to my local repository, right? So in case you are doing it for the first time, you're not gonna get this message. In case you are trying it again, then it is asking whether I want to overwrite it or not. So I'll not overwrite it, right? Because I already have this created over here. Now this public key is for your remote repository. So what you need to do, you need to provide this public key to your remote repository. How you need to do that? Just open this with a notepad, and this is the key that you actually need to provide it to the remote repository, right? So you just copy the entire thing and we'll go to the main like settings, account settings, to add this key over here. So if I go to this setting, it will take me to my profile, and from this I need to select this SSH key. So I already have some of the SSH keys created. I can even delete them, and I can create a new key, right? So if you want to remove these keys, you can add new keys, but I'm not going to do that because I have already configured it. So what you can do, the very first time you need to give some title. Let's say I have given GitHub for Windows, or like this W2APC, right? So you can do this thing, give any title and paste the entire key over here, right? And then hit add key. So it will gonna add a key that is being generated on your local machine, right? And it will map that particular key over here, right? So what are the steps that we gonna follow? I have jotted down all the steps over here. So open the git bash and run the following command and enter the location which these files will be saved, right? So default location is fine, right? So whatever that we have seen, the two files were generated, right? And once you are actually firing this command, I have missed this step, right? So it will ask you for one more additional security, right? That is enter a passphrase, enter a password basically, right? So this is an additional security, right? Although you are mapping the SSH key, but this is an additional security. Let's say if you want that a password should be asked before you check in any code, before you push any code to the remote repository, so you can make this true while generating a key. So it will all the time it will gonna ask for the passphrase, right? So a pair of RSA keys will be generated. One is public and the other one is private. Now these are the steps to add the SSH keys that we have just seen, right? Now let's see how we can permanently store this key with the GitHub. We need to run the following command, right? And this we need to run in the git bash. So how we gonna run it? I'll just be typing ssh-t git at github.com, and when I press enter, let's see what it will gonna do. Okay, it is actually asking for a passphrase, right? Because I have configured it in this way. So if I enter my password over here, so it will say, hi W2A, you have successfully authenticated, but GitHub does not provide shell access. That's fine, but I am successfully authenticated and I am now good to push my code onto the GitHub repository. So now let's go back to our project. Inside this, okay, let's revise what we have seen in like the Git lecture, where we have added our project to the local repository. How are we going to do that? I need to open up the git bash from here, so I'll be opening it from here. The very first command that we okay, let's check what all files that we need to track. So I'll say ls, and it will gonna show me these files that I can track, right? So what we're gonna do, the next thing, we're gonna first make it compatible to git. So the very first command that I need to write is git init, right? And this will actually gonna create an empty repository over here, right? And now I need I'll fire a command that is git status, and I'll gonna see what all untracked files are there and what all files that I need to track, and then I need to commit it, right? So what all files I'll be adding over here, I don't need these class path and .project and .setting files. I would just be needing this pom.xml and my source folder to be pushed to the remote repository. So what I'll do, I need to add them first. I'll say git add pom.xml, and it will add the pom.xml file, and then I'll say git add src complete entire folder, and these two folders are being added. Now I again say git status, and we're gonna see these are the new files that have been added and are ready to commit, right? Now I need to commit this code, so I'll say git commit, and I'll give some message by saying -m, and this message is really important, otherwise the code will not be committed. So I'll say initial commit, right, and I'll press enter. So you can see two files are changed, and what it has done all these insertions, right? So okay, so the next thing is that we're going to see is how we can add a remote repository to the project, right? So in order to communicate with any remote repository, we need to add address of that repository to the project, because there will be a number of repository on the remote side available. So we need to tell our project that it should be communicating to this particular repository. So we need to give the address of the remote repository, and that can be given by the following command, that is git remote at GitHub and the remote repository as a key. So here GitHub is any name you want to give to this project. So how it will gonna work, if you go back over here to the project where we were. So over here you can see these are some of the following commands that we have fired in it, and then add, then commit, right? Now this is what you need to do. So this is the URL, the address of your project where you need to push the code, right? And you'll say git remote add, and you can give any name. Let's say they have given the name origin, you can give origin or any name to this, and then you'll say git push -u origin master. So it will actually gonna push your code to the remote repository, right? So let's see how we're gonna do it. Let's bring up the git bash again. Now there are two ways to add this project as well over here. One is through the HTTP address, and the other one is through the SSH key, right? I prefer it doing SSH key, so that when I make a one-time configuration, I need not to give this key again and again when I'm checking in from this particular project, right? So what we need to do, I'll just copy this command, and I'll go back to my git bash, and I'll paste this command over here. Okay, so it's actually not allowing me to paste like this, right? So git remote at origin, you can change this name of origin to any other name if you want. Press enter, and this is now added. This key, SSH key, has been added to this particular project. And now when you say git push -u origin master and press enter, it will actually gonna push your code to that particular remote repository. So it is asking for a passphrase, because I have actually enabled this option. Every time before doing any check-in, it will actually gonna ask me for whether, ask me for a username, sorry, for a password, right? Alright, so let's see whether the code's been added over here or not. So let's go to this repository, let's refresh it, and you can see the code that we have written, it's actually committed. This is the initial commit that we have done. And let's open up the source folder. You can see the test folder over here, the Java folder over here, and this is the login test.java code that we have written is now onto the GitHub, right? And you can see the pom.xml that we have created, that is also available over here. This is how we can push our code onto the remote repository using Git and GitHub, right? So let's take a look at again what we have seen so far. This is how we have added a remote repository to the project by saying git remote add, and given the name origin and then the SSH key, right? And then we have actually pushed our code to the remote repository by saying git push, and then given the repository name and the branch name, and that is how we have actually pushed the code to the remote repository, right? Now let's make changes to the existing project and see how we can again perform a check-in. push request to the remote repository. Let's say I add some more lines of code to this project. Let's say I write driver dot find elements by dot id of the sign in button, that is sign in, and I'll say dot link, right? So I've done some more coding for the day, and again I want to check in this same code. I want to push the same code, so I'm not going to directly push it to the remote repository. I need to follow the same step again. First of all, I need to commit it to the local repository, and then I can push the entire code to the remote repository, right? So what we gonna do, we if I do git status, it will show me that this is the file that's been modified, and I want to track this particular file. I want to add this particular file again, so I'll say git add, and I can give the entire source folder again, right? So that's been added. Now I want to if I again say git status, it will show me that this is the modified file which is ready to commit. So I will be committing it, so I'll say git commit -1, and I'll say committing the changes made to login test, and I'll press enter, and it will actually gonna add this particular file to the git local repository, right? Now I'll push this code again to the remote repository. So I'll again fire the same command, that is git push -u, and origin was the local branch, and the local project name that we have given, and then the master is the master branch that we need to push, right? And if I press enter, it will start pushing the code, and it will ask for the passphrase, right? So I'll give the passphrase over here as my password, and it will push this entire code to the remote repository. Now let's go to the remote repository and see what all things are being added over here. So over here you can see that there was no change in the pom.xml file, so it is still showing the initial commit as the text, and inside the src you can see committing the changes made to the login test has been added 2 minutes ago, right? And let's see if our changes are updated over here inside the login test or not, and whatever the changes that we have done, it's actually been added to the GitHub remote repository, right? So this is how we can perform check-in and check-out. We can, in terms of Git, we call the check-in as push and check-out as pull, right? So although I mean GitHub is like a world on its own, right? You can create multiple branches as well over here. This is a master branch on which we are working on. Let's say there are a number of developers involved in this project, and if a developer wants to create his own branch, then he can create a new branch and copy the entire code, clone the entire code in his branch. He can then work on that particular branch, and later on he can merge the code with the master branch, right? So GitHub is it's a world on its own. There are so many features available in GitHub, right? But we are not going to talk about the entire features of GitHub, right? We have already take a look at the major feature, that how we can push our code from the Git local repository to the GitHub, right? And these are the things that we would be needing when we might be running our test through the continuous integration part, that is through Jenkins, right? So these are the things that we would be needing at that point of time, right? So if there are any changes made to the code, it will directly go to the Jenkins server, and Jenkins will actually gonna compile, do the continuous integration part, and it will run our build with the help of Maven, and it will execute our code. So whenever there are changes made to the code, at the same time, at the same point of time, your build will be executed, and that is what we will be seeing with the lecture that is for Jenkins, right? So in GitHub, this is all what we have seen so far, right? All right, so thanks a lot.